So, good afternoon to one and all present here. So, now I'll introduce about our guest today. So, Dr. Rajiv Mishra sir is working in the Department of Computer Science and Engineering at Indian Institute of Technology, Patna, and he has obtained his PhD degree from IIT Kharagpur and MTech degree from IIT Bombay in Computer Science and Engineering and BE in Computer Science from MNIT Allahabad. His keen research interests are span a deep learning, edge AI, distributed algorithms for mobile, ad hoc and sensor networks, cloud computing, big data, and wireless networks. He has authored a textbook on cloud and distributed system and web applications, and he has offered online MOOCs on NPTEL SWAYAM in cloud and distributed computing, big data computing. It's a great honor to be here, sir. Thank you so much for accepting our invitation. The session is over to you, sir.
Okay, thank you. Thank you, Sri Krishna College of Engineering and Technology from Coimbatore for giving me this opportunity to make a presentation on the topic that is convolutional neural network. So let me share my presentation. Okay, is it visible? So my presentation is visible to you all?
No, sir. No, sir.
Okay, please, yeah. Please give me the share rights again because it is disabled. It's suppose.
So you can now start sharing it, sir.
No, it is that icon is not showing up. That share icon is not enabled, huh? Oh, can I again rejoin again if you want? Yeah. So you have to unshare. You have to unshare.
Yeah, I'm once again I'm stopping it, sir. Once again I'm stopping it.
Yes.
So now can
Is it visible? Slides are visible?
No, sir, it's not.
No, sir, it's not visible.
Okay, I'll do another join. And make a presentation. Is it visible?
Yes, sir.
Okay. Full screen is visible?
Yes, sir.
Okay, thank you for the confirmation. So let's get started. So the topic of this talk is convolutional neural network for the object recognition. And I will be talking about this convolutional neural networks. Many of you know about this, otherwise we will go and discuss the applications also as a use case for this special type of neural networks. So with this, myself, Dr. Rajiv Mishra, I work at IIT Patna. And let's get started. So let us understand about the dense neural network and convolutional neural networks. So you can see on the left side, this is an example of a 3-layer neural network. And on the right side, the same concept is known as convolutional neural network, wherein you have now the input as the images, and the images are having the width, height, and depth, and as they are visualized in one of these layers. And hello, noise is there, the background noise. Hello. Hello. Is it visible?
Yes, sir. Visible.
Yes, okay, sir, visible. Okay, all of you, please mute your mics, huh? Okay. All of you. Okay, let me get started. So we will discuss these kind of deep, dense neural network, how this is different from convolutional neural network, and what is there inside convolutional neural network. One thing important to understand at this before going ahead is that convolutional neural networks take the image as the input, and the images sometimes may be of 3D images, and all these will be the input, and that dense neural network which processes this image as the input, called convolutional neural network, that we are going to discuss. So CNN, in short, it is called ConvNet. Also, it is known as called convolutional neural networks. So convolutional neural networks are simply neural networks that use convolutions in place of general matrix multiplications in at least one of their layers. So you know that convolutions are the special operations. So it's not like matrix operations. So we will see what do you mean by the convolutions, those kind of operations which are now applicable on the image pixels. They are called convolutions. So this kind of, since it is specialized for the images, therefore it is not only simple matrix multiplication, but these operations which are being performed on the pixels of an image called convolution. And that makes the difference with the normal traditional deep neural networks and convolutional neural network. Here the operations are specialized only for the images. So convolution is the mathematical operation having the linear form. So you can see over here these set of operations which are now being performed on the pixel level at the images called convolutional, and that kind of
Kindly
neural
give the
network.
slideshow of the presentation, sir. Kindly give the slideshow of the presentation, sir.
Sure, sure. Yeah. So are you able to see these presentations? Hello, can you see my presentations?
Yeah, it is visible, sir.
Okay, I'll give you in the end.
Yes, sir, but
sir, it's not full screen, sir.
Actually, there is a problem in.
Okay,
there
sir.
is a problem in. this Google Meets, huh? So maybe
This
that
Google Meets, huh? So maybe that you can see.
So please mute your mics. Okay, let me go ahead. So should I let me just a minute. Hello. Okay, so let us see the applications of convolution neural networks. So convolution neural networks are there everywhere. So the applications of convolutional neural networks are image retrieval, then object detection, then self-driving car, semantic segmentation, face recognition, pose estimation, and detect diseases, and speech recognition, text processing, analyzing the satellite data. These are few of the applications of the CNN. Now, if you see that CNN becomes a core part because it deals with the images and objects, so it becomes the core task of computer vision. So if you see what are the core tasks of computer vision and where this CNN fits, so core task of vision is about the classification, on the classification of an image. So given an image, you have to assign a labeling of the image. So this becomes this is called the classification. Then another task of computer vision is the localization. That is, you have to determine the bounding box containing that object into a given image. This is called localization. And then another thing is called object detection. Given an image, detect all the objects and their locations in the image. Semantic segmentation. So given an image, assign a pixel to a class label so that we can look at the image as a set of labeled segments. And instance segmentation, same as semantic segmentation. So you can see these are the core tasks of computer vision. And what we are now covering is about the convolutional neural network as a classifier. So classification of an image we are going to cover in this particular discussion. Beyond this discussion, you require another higher level this one research base for this localization and object segmentation, which we will present in the end, but not going in detail about it. So we will confine our discussion more on the classifier part. That is how, given an image, you can classify or you can assign the label. So let us understand what you mean by the image classification. So image classification is the task of taking an input image and outputting a class or a probability of the classes that best describes that image. So for humans, this task of image classification is one of the first skills that we learn, and everyone is well acquainted with this kind of skills. However, when it comes to the computer, this becomes quite tedious. So being able to quickly recognize the patterns, generalize from the prior knowledge, and adapt to different image environment are quite difficult for the machines. So this kind of task, which humans are very good at it, is very, very difficult for the machines to do this. So let us see this picture. Here you can see the picture of a cat. So just by seeing the picture, you can identify that this is a cat. But for computers, this particular picture of an image of a cat is represented in the form of zeros and ones in the form of a matrix. So this particular matrix, which computer sees how from this particular image that is in the form of the matrix, it can detect, or it can classify that this is the image of a cat. So for computer, this becomes quite tedious, for which we humans are good at it. So now we will discuss this MNIST data set in great details, after we finish it. So before that, let us discuss this MNIST data set is the data set for the character recognitions. So characters means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 different characters, and they may be written, handwritten. That means everyone is having a different way of writing these characters, and this particular data set is the collection of such handwritten digits. Okay, so we will look up this kind of data set, which is called MNIST data set, has 60,000 training examples and 10,000 test examples, and it's a rank of the best classifiers, and errors are being built based on this MNIST data set. LeNet 5 that we will discuss is also one of the examples around this database that is being developed. That is the first model. So in this MNIST data set, you can see that one such image of a character, let us say that it is written, the digit 8 is written, and that is being captured into 28 by 28 size of image, that is 784 pixels, and the values of these pixels are represented over here in this form of the matrix. Most of these matrix, wherever it is dark, is zeros. Only wherever it is white, some values are there in the integer. Now the task of a computer is to read this kind of input image, that is the data, and from this it has to now classify that this is the image. In this image, it is showing the character, or it is the digit 8. So this is not so easy for computer, but for human, just by looking this image, you can say that this is the digit 8, which is written over here. Similarly, there is another data set called CIFAR, and this has 60,000 32 by 32 color images in 10 different classes, with 6,000 images, and there are 50,000 training images and 10,000 test images. So this particular data set talks about 10 different classes, such as in the previous example, MNIST data set has 10 different digits, 0, 1, 2, 3, 4. But here in this CIFAR data set has images, and these images are of 10 different classes. For example, airplane, automobile, bird, cat, deer, dog, frog, horse, ship, truck. All these images are mentioned over here. So if you see that airplane, different images of airplane is shown over here, and this becomes the part of the data set. Now, another thing about image you have to see is that most of the images are colored images. So if they are colored, so there are 3 different type of color is used in that color images, that is red, green, blue.
Sir, slides are not changing. It is still on the second slide.
Okay. Let me, is it visible now?
This second slide. This is second slide.
Okay, just a minute. A lot of issues are there. I don't know. Is it visible?
Yes, sir, it is visible.
Sir, it is visible, but slides were not changing.
Okay, just hold on. Just hold a minute. Is it changing now?
Yes, sir.
Okay. So I will be using this mode. I will not go in a full screen mode because slides are not changing.
So actually, it's not automatically. It's not changing, sir. You have to manually change that. Sir. Change. You have to click that slide, sir.
I'm doing it, but it is not doing it. So let us bear with this technical issues of a Google Meet. Maybe that at my side there is an issue. Okay, so what I was talking about, let me quickly show all the slides which we have already covered. So I was talking about the area which is called the computer vision. And in that, the core tasks were the classification, localization, object detection, semantic segmentation, and instance segmentation. And out of this, the part which we are going to cover today is about the classification. Okay, so in that classification, you are given an image, and the task of the classifier is to assign a label. The class label, that means what this image is about, that is called class label, and this task is called classification. There are various other tasks. For example, if more than one images are there into an image, one or more objects are there in an image, so you have to enclose the bounding box in that for that object in a given image, and that is called localization. And object detection is that given an image, you have to detect all objects. Maybe that in an image, you are seeing a particular image of a cat, dog, everything is there inside one image. So that is called object detection. So we are in this particular discussion, we are confining about the image classification. Now let us understand what is an image classification. So image classification is the task of taking an input image and outputting a class. Or the probability of the classes that describes the image. So image classification is quite straightforward for human beings are concerned, but it becomes quite tedious when the computers are there. So take this example here in this image, you can see the image of a cat. We can see and we can classify immediately that this is the cat. About computer, you can see the image of a cat in this particular matrix form. It is a lot of digits are there, and it is full of numbers, integers. And using these set of that input data, so computer has to classify that this is the image of a cat. So it is not straightforward, it's very tedious. To train this computers to learn that this is the image of a cat, various efforts has been made in the terms of data set. One such data set is called MNIST data set. It is a specialized data set for the digits, handwritten digits. So handwritten digits data set is quite, and around this to classify these handwritten digits into these classes from 0 to 9, one of these digits. A lot of classifiers have been built and they are being ranked. We will talk about that. And so this is the typical example of the one such handwritten digit, let us say 8, which is represented in the form of 28 by 28 size image, and which is having 784 pixels. So if you see inside the image, what you will find is most of the pixels are having the value 0, and very few wherever you see a white portion in the image, which is displaying the handwritten digit 8 is only having the integer values, and rest are all zeros. So so this is CIFAR dataset, and this dataset is the dataset of 10 different classes such as airplane, automobile, bird, cat, deer, dog, frog, horse, ship, and truck. It comprises of 60,000 different color images. Now, another important thing about the images is that most of the images are colored images. So colored means the same image has the red color, green color, and the blue color. So you can see there are 3 dimensions. If you see an image that is in RGB form, so that is what is also additional information which is to be required to process these colored images. So that is what I have told, that if let us say you have the image of image and which comprises of m rows and n columns. So for every color, that is red, green, blue, you have to have such input, and each value of these particular cell is called a pixel. So it will be having its value in the integer. So this is a typical colored image, which is 3 different depth is the 3, that is blue, green, and red. And the sizes of each of these images m rows by n columns. So it is having a 3-dimensional input. When you talk about the image, that is, it is having m rows, n columns, and there are 3 dimensions, that is red, green, and blue. Now we will talk about the deep learning. Is a new area of machine learning which has been introduced with the objective of moving machine learning closer to one of its original goals, that is the AI. So key concepts of deep learning is that deep learning networks are distinguished with more common single hidden layer and neural networks by their depths. So more than 3 layers, when you say that it qualifies the deep learning or a deep neural network. So deep learning network, each layer of the nodes trains distinct on a distinct set of features based on the previous layer's output. So you further, if you advance these neural networks, the more complex these features your nodes can recognize, and they then aggregate and contribute more features than the previous layers. So typical example of a deep learning is deep neural network. Then you can see that convolutional neural network is a deep neural or a deep learning model that we are talking about, which deals with the images. So convolutional neural network, when you talk about, they are inspired biologically from the visual cortex, that is our eye system. So that from inspiration, that is biological inspiration, from there it is being designed, and that is called convolutional neural network. So as you see that our eyes are specialized to seeing, to understand what it is seeing from the external world, physical world. Similarly here, this convolutional neural network also is specialized that if you give an image, it will be able to identify or classify, or it will understand the image. So this understanding is inspired, this entire computation is inspired from the biological visual cortex. So the visual cortex has a small region of cells that are sensitive to the specific regions of the visual field. For example, some neurons fired when exposed to the vertical edges, and some when shown the horizontal or the diagonal edges. So therefore, in any image, you can see these are the different features which are having the edges, and these neural cells in the visual cortex. These are looking for the specific characteristics is the basis of the CNNs. So let us go inside the CNNs. So as you see that it is inspired from the biological cortex, and this entire model, mathematical model, is designed, which is specialized for processing the images, called convolutional neural network. So let us see a typical architecture of the convolutional neural network architecture. So this architecture has layers. It is divided into convolutional layers, then pooling layer, and then fully connected layer. So 3 different type of layers are there as far as convolutional neural network architecture is concerned, convolutional layer, pooling layer, and fully connected layer. We will understand this in more details. What do you mean by convolutional layer? What do you mean by the pooling layer? What is fully connected layer? Now, convolution, as I told you, that it's a mathematical operation defined for performing the operations on the images, pixels of the images. Therefore, they are called convolutions. It is not simple matrix multiplication. It is not simple matrix related computation. So take this example here. In this example, you can see there is an input image, and this input image, to understand, as far as from the eye, you can immediately see that this is the picture of a robot. But as far as for computer to understand that this is the image of a robot, it has to first understand the edges which are involved in in identifying this object, which is called robot. So edges and lines, all these things are there, and then different colors and shades. So all these things requires the understanding of these image features. To detect, to understand these image features, the operations which are involved at the pixel level is called convolutions. Now, so this particular convolutions are nothing but the mathematical operation after the convolution, that is first level understanding. The image features will be now noted down into another intermediate form, which is called feature map. So feature map contains these features of the image, which are understood using the mathematical operation called convolutions. And then you have the subsampling, and then you have to perform again the convolution to have more understanding, means other features and so on. Finally, this will converge into the fully connected layers, and the last fully connected layer will output what this image is, and hence its classification will be performed. Okay, so let us understand the operations. What are the convolution operators? So convolution operators, you can see that if it is an input image is given, which is represented by I, then you require to perform the convolution operators, you require the filters. So filter or the kernel. Here in this example, it is shown the 3x3 matrix K. It is called the kernel or the filter or the feature detector. And the matrix which is formed by sliding this filter over the image. So this filter, you can see that when it is slided on this input image, that means in this example on the right side, you can see that this filter is positioned on the top corner, topmost left corner. You can see it is superimposed. So the filter has 1 0 1 0 1 0 1 0 1. When you place it on the input image, so what you will find here is that already 1 1 1 0 1 1 0 0 1, it is already written. Now you have to perform this mathematical operation. This operation is the dot product. So the dot product of this filter, which is having 1 and input image is 1, 1 and 1 is 1, then 1 and 0 is 0, 1 and 1 is 1. So so 2 ones are there, and then again 0 0 0, 1 and 1 is 1. The 3 ones are there. Then in the last row of the filter, you will find only 1 1. So 4 ones are there. So if you sum them, cross product, and you make a sum, so that becomes 4. So convolution operator, which is shown over there above, using this mathematical equation is about the dot products and then make a summation of it, and this becomes 4. Similarly, the next cell in the convolved feature map, let us understand. So if you stride, that means if you shift this filter one on the right one row, then let us understand what will be the value of this convolved feature. So it will become 1, it will become 0, and it will become 0. So in the first row it will become 1, in the second row it will become 1, and in the third row it will become 1. So there are 3 ones. So the value of this convolved feature just besides means after 4 it will come 3 and so on. So this particular operation can be performed. Let us go and see the next slide in more details. So for example, if you are given an original image of a mouse, and you want to detect using the mouse. So to detect that this is the mouse, this is the image of a mouse, you have to detect all the edges which forms a shape of a mouse. And for this you require different kernels. And here in this, that is kernel means filter. And here, and you have to perform this convolution operator, that is nothing but the dot product and the summation of that. And let us okay, so this particular convolution operator has a different function. For example, if you want to, there is a filter which is called the identity operation. And you can see that if it is applied on this input image, you will get the convolved image in this manner when a filter is applied over there. As far as the edge detection is concerned, so for the edge detection, you have different kind of edge filters. So there are 3 different edge filters are given, and it will be able to identify the edges into the filter. Similarly, there is a filter called Sharpen Filter, and this particular 0, -1, 0, -1, 5, 1, -1, 0, -1, 0. So this is called Sharpen filter. And when you apply to this input image, so you can see that all these features are sharpened. In this box blur is also another type of filter. So you can see that Gaussian filter is also there. So you require these to perform this convolution operator, you require these different filters, and this particular different filters will produce different feature maps for the same image. And this example which we have shown you to motivate you that to process this image, to understand this image, you have to understand the features of that image. To understand the features of image, you require different type of filters to be applied simultaneously on the image, and you will collect those features into the map called feature map. So this is input image, and let us see input how this input will be the image will be computed. So let us go in more detail of understanding this convolution operation, which is their part of convolutional layer. So here you can see that the image, which is a colored image, has the red, green, and blue. So they becomes 3 different channels. So the image has 3 different channels because 3 different dimension is there, and size is 5 by 5 matrix. So 5 by 5 matrix multiplied by 3, that is 3 dimension. That dimension becomes the channel. Now you have the kernel for channel 1, which is -1, -1, 1, 0, 1, -1, 0, 1, 1. This is the kernel 1 for the red color. And this particular 5 by 5 image is now padded with the zeros. You can see that so zeros are being padded. This is this particular padding is done to retain the size of the image of the 5 by 5 size. Otherwise, the size will reduce, and then perform this convolution operation. So this particular example, which is shown as an output, that in a kernel, this particular image, which is having, let us say that 0, 1, 1, 0, 1, 0, 1 minus 1, 1. So let us see how it will calculate. So if you perform this convolution operation, so what it does is it will become 160, then 163, and then it will become a minus 160, and then 160. So okay, so 3 plus 1, 4, that is 164. And you have to add some bias to it, and finally so this will become corresponding values, because you can see that 308 is the value which is which you are getting out of channel 1, that is from the red color. Minus 498 you will get from the green color, and 164 you get from this. So if you sum them, that is 308 and 308 minus 498 and 164 minus 498, 164 plus 1, this becomes minus 25. And you can see that you are taking the image which is of the dimension 5 by 5 by 3. 3 means red. There are 3 channels, that is red, green, and blue. The output you will get here, you can see that 1, 2, 3, 5. So it is, you see that 5 by 5 size output you will get if you pad in this manner with the zeros and then perform the convolution operation. And its dimension will be 1. Why? Because all values of red, green, blue is collapsed into single dimension. So the output of this convolution operation will shrink the dimensions into 1. That is 5 by 5 by 1. So if you have anything, any question at this particular moment, you can ask me at this stage. Otherwise, I will go ahead. So in this, so if there is no question, so let me summarize what are the different things I have discussed here in the convolutional neural network, that is convolution operation, is that you require a kernel, and this kernel is well-defined filters to detect different features of the image, and the image which is given as the input is having important property that it is a colored image. So when you say colored image, which is formed out of red, green, and blue, and the size of this image is 5 by 5. Now, if you want to retain the same size as the output, so you have to do zero padding. So zero padding means the zeros are filled in the rows and the columns above. So that means it will form 6 by 6 matrix, not 7 by 7 matrix. Zeros are padded over there, and then you perform the convolution operation that I have explained. So with this explanation, let us go to the next slide. We will discuss this in more detail about this. So as far as in convolutional neural networks, so convolutional layer, in practice, the CNN learns the values of these filters on its own during the training process. So although we need to specify the parameters such as the number of filters, filter size, padding, stride before the training process, rest of the things will be learned from these training process. And now the next issue is the next layer, which involves an operation called activation layer. So rectified linear unit ReLU is an additional operation which is to be used after every convolution operation. So you can see in the ReLU what it does is if it is minus, so it will output 0, and if it is any positive value, then the same value will be produced. So the function of ReLU will be like this: the maximum of 0 and the input will be the output. So ReLU is an element-wise operation that is applied per pixel and replaces all the negative pixel values in the feature map by 0. The purpose of ReLU is to introduce non-linearity in the network. So in this activation layer, that is, we have talked about the convolutional layer, and then we are talking about the activation layer. And one such function, activation function, that is ReLU, we have discussed. Okay, so so here you can see that if it is a black is a negative value and white is a positive value. So you can see that if you apply the ReLU function, that is the black means negative is being suppressed with the 0 value. So there is no negative is present on the right side. There are other nonlinear functions which are there in the activation layer, such as tanh and sigmoid. Can also be used instead of ReLU, but ReLU has been found to be performing much better in most of the situations. So hence ReLU is the most popular activation function which is used in the activation layer. Now after this, that means convolutional layer and activation layer. Now you have another layer which is called a Pulley layer. So Pulley layer downsamples the volume especially and independently in each depth slice of the input. So take this example that if it is a volume that is 3 dimension, 224 by 224 by 64, then you know that if you apply the pooling, then it will downsample the volume especially and independently in the depth. So you see that depth is 64, which is not changed, whereas the 224 by 224 is reduced, downsampled into 112 by 112. So this is done, downsampling in the volume especially is done without independently being touched in the depth of a slice input called pooling. So pooling performs this operation. Let us see how the pooling does. So the most common down sampling operation is called the max operation, and so it will give rise to the max pooling, as shown in the example with the stride 2. Stride means shifting 2 times. So here you can see that the max pooling is performed in this manner. That is, it is shown over here that in this example x by y image, you can see that if it is given, then you can see 1 1 5 6, that is 2 by 2. The size of the stride, the size of this max pool operation is 2 by 2, and so 2 by 2 filter is used in this max pooling with the stride 2. So 2 by 2 filter means you can see 1 1 5 6, and if you take the maximum values out of 1 1 5 6, it becomes 6. So in the max pool, it will take the maximum of all these filter values. And stride 2 means you have to shift 2 places on the right. So the next filter will be 2 4 7 8, and the maximum value is 8. So 8 is written over there. Similarly 3 2 1, 2. So the maximum value is 3. So 3 is written over there, and 1, 0, 3, 4. So the maximum value is 4. So meaning to say that if you want to downsample, keeping all the properties or the features of the image intact. So the dominant means the maximum will take out all the important features of the image, and size will be reduced. That is called downsample, and this operation is performed in the pooling layer that is shown over here. Now you can see over here that convolutional neural network has the last set of layers, which is called fully connected layers. So the neurons in the fully connected layer have full connections to all activations in the previous layer as seen in the regular neural networks. So, so this is what you have seen. So what we have seen is that in the convolutional layer, then you have a ReLU layer, and you have a pooling layer. So convolutional plus LeRU is called convolutional layer and pooling layer. So convolutional pooling keeps on repeating many times, and its intention is to extract the features. So feature is drawn over there. After that, this particular image is being flattened, and then given input as to the fully connected layer, and then fully connected layer will be applied the softmax function, which will classify whether it is one of these whether it is one of the digit from 0 to 9, or it is from 10 different classes image it is there, and so on. So this becomes fully connected layer will now finally, after extracting the features, after learning the features in the convolution layer and the pooling layer, it will now perform this classification, which is shown over here. Okay, so let us see here in this example that this is the example of a convolutional neural network wherein the input is given the input of image of a car, and it has to classify whether this object, this image of a car, it is a truck, airplane, ship, or a horse. So that is 5-class classifier. It is that this convolution neural network. So it comprises of convolution layer and the ReLU layer 2 times. So you can see that convolutional ReLU, convolutional ReLU, 2 convolutional values, and followed by a pooling, and it is being repeated 3 times. So you see that convolutional ReLU is then after the output, 2 output is given to the pooling layer, and this entire thing is repeated 3 times. So it is written in this manner, and then this entire thing is given as the output to the fully connected layer, and fully connected layer using softmax function will classify this particular image into these different type of classes. So this is one typical way of writing this convolutional neural network. Let us understand once more before we go ahead about all these operations. So convolution operators requires a kernel, and kernel is a small part of an image, and from there it will try to understand or learn the features, and it convolves means is rotate into. So in this example it is shown that in a given image, you know that this kernel is convolved. It will perform this convolution operation, and then it will shift and keeps on means sliding into the entire image. So it will using these kernels, it will try to extract the part of the image called features, and this will be stored into the into the table called feature map that we have already told. As far as this convolution kernel is concerned, this example is shown over here is that if this is the kernel of 3 by 3 size 0, 0, 0, 0, 1, 1, 1, 0, 2, and okay, so this is mapped. This kernel is 4, 0, 0, 0, 0, 0, 0, 0, minus 4. So if you apply the convolution operation, so the value of this dot product becomes -8. So this calculation is shown over there in this particular slide. So that you can see that how the -8 will come. So -8 will come. Can see that 2 multiplied by -4 becomes -8, and rest all it will be 0. Now, if you want to retain the same size of the image, that is 1, 2, 3, 4, 5, 5 by 5 image, so you require to pad the zeros at all the sites. So padding on the input volume with the zeros in such a way that the convolution layer does not alter the spatial dimension of the input. And so this is called padding operation. Now the next issue which we have discussed is after this convolution operation, then we require this operation called ReLU. That is, ReLU layer will be performed. Activation, that is convolution and then activation together is called convolutional layer. So then rectified linear unit ReLU, what it does is wherever minus values are there, it will convert into 0, and rest all values will be there. And that is widely used activation function. Other activation functions are already there. After this convolution and activation, you have a layer called pooling layer. So pooling layer will downsample the size that I have already explained. And this example, you can see how the size, how the dimension is reduced. Downsample. Downsample means that 224 by 224 is reduced to 112 by 112. Just half of the dimensions of this particular images. So this is the downsampling, and it requires the filters. So this is example of a max pooling operation in the pooling layer. So max pooling, what it does is it requires a filter of 2 by 2 size with a stride of 2. It will generate a sample. It will generate the output of a size 2 by 2 from the image of 4 by 4. Okay, so pooling layer downsamples the volume spatially independently in each depth slice of the input volume. So in the left, in this example, we have shown the input volume of size 224 by 224 by 64. अभी मैं बिजी हूँ तो मैं बात हुआ. Okay, so this is an example which will use the filter of size 2, stride of size 2, and it will generate the downsample of size 112 by 112 by 64. The most common max pooling operation is called max pooling, that we have used in this example to show you this example, and this particular max pooling is shown over here. Similarly, you have another type of pooling called average pooling, is also can be used, which is shown here in this example. Therefore, let us summarize about the convolutional neural network what we have discussed. So a convolutional neural network is the simplest case of a list of layers that transforms the image volume into the output volume. And there are a few distinct types of layers which we have discussed: a convolutional layer, a ReLU layer, fully connected layer, and each layer may or may not have these parameters. Each layer may or may not have additional hyper parameters. So these are some of the things which is to be known. Now we are going to discuss a special type of or a classical convolutional neural networks that is called LeNet. This architecture is an excellent first architecture for CNN, and this particular LeNet was developed as a CNN to recognize the handwritten digits. So this handwritten digits, you can find the use whether it is in the checks or in most of the documents where the digits are nothing but the money value or some values are there. So how to read these handwritten digits into from these checkbooks or from other documents. The LeNet 5 was initially developed as the classical model, classical architecture of for the CNN based classical architecture, classical models. So LeNet 5 is one such architecture. So so LeNet 5 was designed to have this handwritten character recognition, and it is having an application in recognizing handwritten values into the checkbooks or in other documents. So this architecture, let us understand that this particular LeNet 5, which has the use, which was used heavily for understanding the handwritten digits in the checkbooks and other things. Let us see inside this what kind of architecture it is used to build this CNN-based model. So input is, let us say that any document image, let us say image of a checkbook, and from there you have to detect how much is the value. The numbers, handwritten numbers are written, what value it is asking for the withdrawal in the check. So input is there. So to understand, to classify these digits, what it does is it takes these input and perform this convolutional layer. So convolutional layer means it uses the kernel. What kind of kernel it uses to recognize the handwritten digits? So handwritten digits, to recognize handwritten digits, it must have the small circles, two circles in digit 8. One circle in let us say the digit 9, and lines are there, vertical lines are there in 9. So all these different features are required to be recognized. So for that you require different kind of kernels, and this convolutional one will apply convolution operator using these kernels. So you can see that it has different channels. So that many number of filters it requires. Then it comes the downsampling called Pulley Layer, and then another convolution layer, pooling layer, and finally it will output. That what are the digits written over there into the checkbooks. Let us go in more detail about understanding this particular concept. So this image is taken from the original paper, which is okay. Let us understand this particular. So here you can see that this input is 32 by 32. It is having a black and white image. It's not the colored image. So it is the image is 32 by 32 input size, and then it will perform this convolution operation. So convolution operation, you can see that it will generate the feature map 28 by 28. That means it is not padding up because the input size of the image is not preserved after the convolution operation. So after the convolution operation, the dimension reduces from 32 by 32 to 28 by 28. So therefore, padding is not used in the original architecture LeNet 5. Another thing is it is written 6. So 6 means 6 channels will be created. So that means 6 channels means 6 different filters or the kernels is applied in the convolution layer, and together it will generate the feature map. So feature map has 6 by 28 by 28. So 28 by 28 by 6. 6 is the channels or the dimension it will create because of 5 or 6 different filters. Then it performs the pooling layer, and pooling layer will do the downsampling, subsampling. So subsampling or the downsampling will reduce the dimension. As I told you that it will reduce the size without affecting the dimension. So 6 will be retained as it is, whereas the dimension will be reduced to half. 28 by 28 will reduce to 14 by 14. Now here, this particular original design, that is LeNet 5, has used the average pooling. It's not max pooling, but nowadays only max pooling is more popular. And after that, so that means convolution layer, and then max pooling layer. Again, it will perform the convolution layer. So convolution means this time convolution operation will perform on these different images. So you can see that this particular operation will have this convolution operations will change the dimension into from 14 by 14 by 6 to the size which is called 16 into 10 by 10. So 10 by 10 in the sense, again, I'm telling you that convolution is not performed on the padding. So therefore, from dimension 14 by 14, it will, after the convolution, it reduces to the dimension 10 by 10, whereas it is giving you the 16 channels. That means 16 different filters are applied over here, and for each filter you can see these particular dimensions are increased. Anyone want to ask something? Hello, please mute your mic.
Professors, if you have any queries, you can post it in the chat.
Yeah, thank you. Hello.
Sir, I think, so no the queries, sir.
Okay, I'm proceeding. I'm moving.
Okay, sir. Thank you, sir.
Hello. Yeah, so you can see over here that at the layer C3, you have 16 different dimensions which will be created out of applying 16 different filters, and it will reduce the convolution operation will reduce the dimension from 14 by 14 to 10 by 10. And then you have another downsampling pooling, and this will reduce to the size from 10 by 10 to 5 by 5. 5 by 5 at the rate 16. That is different. That is the dimension will be retained in the pooling layer, and it's called subsampling here in the original LeNet architecture. And then you have okay, then you have the fully connected layer, and out of the fully connected layer, you will get the classification. So classifier using software function, it will give you 10 different outputs. So that is what is shown over here. Now, another architectures are also there. That is CNN-based successful architecture called LXNet. And LXNet was used for winning the ImageNet competition. And so ImageNet competition means it uses that another ImageNet data set. And this particular challenge for that LXNet architecture was being formed. It has C1, C2, C3, C4, C5 are different convolution layers. And then it will be having the fully connected layer 6, 7, and 8, and it will produce the output. This is another such successful CNN architecture which is being applied for. Then you have other CNN architecture which is called VGGNet. So in all these architecture, you can see that it starts with the convolution plus ReLU layer and then max pooling, and this keeps on repeating many times, and then finally it will have the fully connected and ReLU layer, and the soft max will do this classification. Similarly, if you compare this LXNet versus VGGNet, what you will find here is that this model becomes more and more complex. When you say more and more complex, means more features accurately they are able to identify. So therefore, this more because LeNet 5 was very simple model which uses only for handwritten character recognition. And later on, this object recognition of different type of objects to recognize into the image, these are there. So I'm not going in more detail about the training. So training process requires the back propagation. So far I have discussed about forward propagation. Back propagation says that this model predicts the target and how it is different from this prediction from the actual image of a particular of an object. So this particular difference becomes the error, and this forms the cost function, and the error in the prediction of this particular model is is back propagated with the correction at all the layers, and this particular method is called the learning using gradient descent method. Stochastic gradient descent is used here in this particular method. This training has several problems which is called overfitting, and this overfitting problem will be solved with the help of regularization. Regularization says that this overfitting means the accuracy in the training is more, but when it sees a new data set, it will not give you the correct prediction. That is called overfitting. And so overfitting will be reduced using the concept which is called regularization, which is being taught to you earlier also. Now these models which I have discussed, they also can be used for any other applications, provided some modification the layers are being made. So you can see that this, if you use the pre-trained models with some layers modified, then it is called the transfer learning. So here you can see that the most pre-trained models use the ImageNet data set, and these pre-trained models will replace the final layer. Final layer means your fully connected layers will be replaced with the additional layer depending upon that application. And then train the model and then use it, and this way it is called the transfer learning, means you need not have to develop the the new architecture from the scratch. So I think I have covered many other slides for the object detection, and which will be taught to you in this part of the course. Let us quickly surf it. If anyone want to ask these questions, for that you require to study beyond this CNN that is called RCNN, the region-based CNN, and a lot of development has happened into these models to make it more fast so that it can be used in the self-driving car and all that thing. So I have skipped all that intentionally, and now it is the time to ask the questions from the audience. So if you have any questions, you feel free to ask at this moment.
Participants, if you have any queries, you can ask, sir, and get clarified.
So participants can write their queries on the chat box also, so that I will be able to answer them. So there are some questions. I haven't read them. So Priyanka Patel was asking about what are the channels 6 and 16 in the slide. So channels, in the sense, it's a dimension. So you see that 10 by 10 image by 6. 6 means 6 different kernels are used. For every kernel, you will get a different feature map. So feature map, how many feature maps are there? That becomes the channel. Is it clear, or should I make you clear through the slides? Okay, thank you very much. So whenever somebody asks you what is the channel, you can say that if it is 16 channel, then you have to say that 16 different filters are applied on that image. And each filter is recognizing a particular feature into the image. So 16 different filters are required, because if the image is very complex, so more filters are required. For example, if it is a handwritten digit, so handwritten digit means if you write down 1, it is only one line, okay, vertical line. If you are writing 8 means 2 small circles are there. So you require one filter to recognize the circles, one filter recognize the vertical lines, and then you have a 2 means one horizontal line also require 3 filters. So maybe that in this LeNet 5 different filters are used to recognize. So the channels are 5 after the convolution layer. So is it clear, Priyanka? So that means if the image is more complex, then obviously you require more filter. The image is more complex. More complex in the sense it is not as simple as handwritten character recognition. It is more complex. To recognize aeroplane, or to recognize the bus, or to recognize something else. For that you require more filters. So so that is why you see different architectures are available for this kind of design. Any other questions you want to ask? So somebody is asking about the ReLU, rectified linear unit leaky, and hello. So ReLU is one more clear. It's the number of filters. Yes. So channels means the number of filters. In a very simple terms. Okay. Now rectified linear units, which you are talking about. So as I have explained that rectified linear units is rectified linear unit called ReLU. I have explained that whenever there is a negative value, it will reduce it to the positive values. Whereas the leaky ReLU is a type of activation function which is based on ReLU, but it has a small slope for negative values instead of the flat slope. This type of function is popular in the task where we may suffer from sparse gradients. For example, training generative adversarial network and all these things. So this is a very high level, next level of design applications. Here it is not used. Mostly it is for other type of deep neural network called generative adversarial network. There leaky ReLU is used. Here we are using ReLU only because it is used here for image classifier we are talking about. And real-time video processing, all these things are the higher level computer vision technique. There all these features are used. So our lecture was confined to the image classification using CNN and the simple model called LeNet 5 we have. So Madhusudan, you are asking a high level question like real-time video processing, that is computer vision related aspect. They are more advanced activation function called leaky ReLU will be applied. Okay, is it clear? So okay, so in the ReLU we have only assumed that if it is -1, if the values are -1, it becomes 0. But here you have in leaky you have slightly sloped values, so it's not 0, something else will be there. So yeah, so this kind of activation function is required in generative adversarial network, but not here. So any other questions you want to ask? So if no other question, then let me thank all the participants and the organizers for inviting me and giving me this opportunity to interact with you on this topic, that is convolution neural network. And we have kept for the image classification, and we have also covered the simple model for handwritten digit recognition using LeNet 5. Thank you very much.
Thank you so much, sir. It was a great session today for us to have you. Thank you so much, sir.
Okay, bye.
Okay, bye.
Participants, please wait for the next instruction.
Manigan, sir.
Ma'am?
Kindly stop the recording, sir.
Kindly stop the recording, sir.
Yes, ma'am.